Okay, this figure legend might have been a little bit more complicated because there's 3 panels. If you wanted to, you could, in a paper, label these panels A, B, or C, or you can simply refer to them as the data for 22 degrees, 26 degrees, and 30 degrees, as long as you clearly note that the reader should be looking at 3 different sets of results and comparing them. And you might have written something that focused on paramecium. You might have said something like, paramecium persisted in competition with coppidium at 22 degrees and 30 degrees, but not at 26 degrees. Or you could have said the opposite. Paramecium went extinct when competing with coppidium at 26 degrees, but persisted at 22 degrees and 30 degrees. And the point here being that, however you described it, whichever way, it actually supports the prediction that we made, that we see paramecium grow to a fairly stable population size, whereas here we see it start to grow and then goes extinct. And that's exactly the range of temperatures where we thought it might go extinct, right in the middle, where there's a decent K for coppidium and a decent alpha competitive effect for coppidium, which makes it less likely that paramecium is going to be able to deal with the competition that it faces when it sees coppidium in the environment. So this brings us to the key point for this lecture, and that is that competition will prevent species from coexisting when their niches overlap substantially. Well, what do we mean by substantially? Well, that's where the devil is in the details. It comes down to those values of K and alpha, or K and beta, if we're talking about the other species. And substantially means that those values have to be small enough that the other species can persist. And if we wanted to put this in the framework of the last video, we talked about fundamental niches and realized niches briefly towards the end. We can actually now ask ourselves, what is the fundamental niche of paramecium? Well, when we just grow paramecium by itself, it grows over the entire range of temperatures. But if we were to grow paramecium in an environment with coppidium, we find that even though the fundamental niche is the entire range of temperatures, what it realizes, the realized niche, is actually only low temperatures and high temperatures, and it can't persist in an environment with coppidium at intermediate temperatures. And so in competition, the realized niche is a fraction of the fundamental niche. And that concept is important to apply to natural environments, not just laboratory or experimental environments, where species are living with all kinds of others, whether they be competitors or predators or even parasites, and sometimes even mutualists, which might actually help you expand your realized niche. And so we're going to start to talk about some of these things in future videos, but keep in mind that the models give us insights into the things that we expect to see in nature. And it's very gratifying when a model like this can actually match up with the predictions that we see in an experiment, because it tells us that competition really is important in structuring the interactions between species.